crystal growth cell. The instrument, the entire instrument which has optics and everything is called the fluid experiment system. This is, so you can see that inside there is a sophisticated optical techniques, holography, with lots of lasers and everything there, and I'm not going to go detail of this. And this is the whole that panel where the whole instrument goes in, and it has all kinds of cameras and all kinds of other things. These are the results. The basic thing which we measure in a sensor crystal, which is detector crystal, is what we call as detectivity. So if you look at the data here, this is a microgravity ground crystal. In the Space Lab 3, it was not a very good crystal because we had problem in the instrumentation and the design and the working. The instrument failed in the beginning and there were problems in the shuttle. So it was not a very good crystal. The detectivity was only 0.99, which is not great. But in the IML mission, so this is a one ground crystal on the ground on 1G environment. Detectivity was 3. But when you compare with the IML crystal, detectivity was about 4.2. So it increased tremendously, increase of that. So the crystals which were grown in the space environment, an IML-1 mission, microgravity grown, these had much higher detectivity as compared to the ground crystal. And that told us that we have better crystal growth.
This is a design question, but you know, you're working with optics, you're working with crystallography, seed growth. When you see the space shuttle launch, it's millions of pounds of pressure, lots of shaking, lots of everything. How do you all design to keep the
Every
integrity
single
of...
part has to be, for example, since you asked this question, let me tell you this. When we flew the experiment, and when the space shuttle went up, and when the astronauts started the experiment, opened the chamber and looked at the crystal, we were worried, nervous like anything, because I was so worried that the crystal seed which I have mounted using a glue stays there and the crystal doesn't fall out, seed crystal. If the seed crystal falls out of that sting, the whole experiment is scrapped. You cannot do anything. So before the flight, I tested in this lab and at NASA every single adhesive which America produces. 3M company, we wrote to 3M, I said send us one tube of every single silicone adhesive. So we had about 7 or 8 different adhesives. And we tried, we built a chamber in TGS solution at 40 degrees, we kept it there, and Lloyd actually built a bar on which we pulled 7 seed crystals and put that in the fluid using different glues and kept it for 7 days to see whether they stay. Some of them didn't stay for 2 days, they fell out. So we knew that which one is good. And then we took the whole system to NASA and put it on an acceleration device which can produce about 8 or 10 Gs, which is a very big shaker.
Right.
And we tested all these glues. So your point is right. We were all prepared. Just like the lasers. Before IML Space Lab 3 mission, nobody in the world knew that how the helium neon laser will behave in space. Because nobody has flown it. And we didn't even know whether the laser will behave as a lasing in a vacuum. So before the flight, we took a helium neon laser, and Dr. Wilcox himself flew on this, what they call NASA has a flight which goes...
Vomit comet.
Yeah, right. So he took that laser in that airplane, which makes loops like that. It creates low gravity for a short period, and look at the laser lasing. So we had to. So that's why I'm saying that experiment of the shuttle, it really involves lots of people, all kinds of people, optics, theoreticians, all, because lots of minds are put in there. Because we have to monitor the experiment 24 hours a day. So in the lab, in the control room at NASA, either in the science area, either myself, Dr. Agarwal or Dr. Patra, we stayed 24 hours, one or the other. And then they were engineers, they were Dr. Wilcox and Dr. Troninger, everybody was in Huntsville. And we were shifting, and there were hundreds of NASA people sitting there all the time.
Your presentation is similar to the NSF presentation, right? Except for
Pardon?
the second part. This presentation is exactly similar to the NSF
Yeah,
presentation.
yeah.
These are the same audience.
The one will on Monday? So let me just go through, we can talk
I mean,
about.
if
Yeah.
you want, because
Yeah,
you
I
want to
can
repeat
skip.
the same thing again.
Yeah. Let me just show you this. This is very important. We will still see it again and when we talk on Monday. That this is a Schlieren picture. These are the interferometric iso concentration lines. Like if you look at the fluid in space and take a holographic data, these concentration lines indicate that this is a crystal here and the concentrations are changing, but they are all uniform. If the G environment of the space shuttle is constant, then all these contours will be uniformly. But if you do the same experiment in ground, you don't have the G, you have a gravity here, which is like this, falling towards the ground. And that's why the concentration lines are not like this, they are pointing towards the earth. So this is, we will talk about next Monday, about X-ray data. This is a crystal which is cut from the flight gate crystal. And if the seed crystal is somewhere here. But when we cut a slice and look at the topographic picture by X-ray techniques in Brookhaven National Lab, we could not see a demarcation line where the seed is. So that shows that the diffusion was predominant there, is no convection. This is a crystal. Dr. Agarwal is mounting a seed crystal in the control room at NASA, because before the flight we need to mount the seed and it goes into the whole system. And we were in the clean room, which is a clean room of 10K, I think. And we know more than 10 particles per square inch, that's what it means, I think 10K.
Yes.
Yeah, 100 particles, yeah. So this is one of the instruments. We were testing the instrument before the flight, myself and Dr. Roger Cruz. This is a picture, my picture when I was lot younger. Lots of hair. This is with Dr. Von Braun, Werner Von Braun, when I was a postdoc. This was my lab director, Dr. Heller, who was a German scientist. And this is one of the astronauts, Roberta Bondar, who was from Canada. She is the one who did the experiment in the space shuttle, the IML-1 mission. And on the side is me and my wife. Both we were together in a garden, relaxing after the mission. And this is in the control room when the shuttle was going up. We were sitting in the room, watching and keeping our fingers crossed so that everything stays right and the experiment goes well. You can see that everybody's eyes are on a monitor. It was there somewhere, Agarwal and Dr. Batra, myself, and all the NASA people are standing there in this room, and there were hundreds in another room. And this is a picture taken at A&M. This is one of the astronauts who came to give a talk here some time back.
Do you see a Nobel Prize winner?
Nobel Prize winner, yeah. This is one of the Nobel Prize winner. Eric Cornell.
Yeah.
He is from Boulder, Colorado, and he came to give a talk at A&M. This is Dr. Shipman. He used to be the dean.
Is that the one that lost his arm, Dr. Blau?
Pardon?
Is that the one that lost his arm?
Yeah, he lost his arm. He had some disease. They had to amputate his left hand. Unfortunately, he was a very young scientist. I think he was one of the youngest Nobel laureate. He got the Nobel Prize when he was only 38 or 39. 34. Yeah. And the work which he got was on his work when he did his PhD at Harvard.
usually like, you know, when they're close to their deathbed, then they will give him everything.
Yeah, so he was at a Cornell,
Yeah.
he came here a few years ago. And this is when I was leaving for India after finishing my 3 years postdoc period. Dr. Von Braun invited me and his wife, my wife, in his office and took lots of pictures, and this is one of the pictures with him. And this is a group of people who worked with me. This is Dr. Tollinger, Dr. Wilcox, Von Braun, this is Dr. Roger Cruz, this is another optics person at NASA. This is Dr. Stullinger. He was one of the German scientists. He was the lab director at Marshall. He passed away a few years back. This is one of the astronauts who flew in the Space Lab 3 mission. Ludwig Vandenberg, he has been to this lab and gave talk many times. This is Norman Thagard, who flew in the space shuttle and the space station and stayed there for 6 months. He was the mission scientist for the IML mission. And this is Dr. Batra, Dr. These are the TGS crystals of different kinds, and you can see that the morphology of the crystal changes with dopings. When you put different impurities in the crystal, some of them grew elongated. This is the natural crystal, and all that. That's all.
Any of you have any questions?
Yeah.
I have a quick question.
Yeah.
The parameter detect